Alright guys, today's goal, the learner will understand how to use the quadratic formula and the discriminant. Quadratic formula. Let a, b, and c be real numbers such that a cannot equal 0. The solutions of the quadratic equation ax squared plus bx plus c equals 0 are x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Alright, so notice it has to equal 0. So if we look at this first problem, we need to get it equal to 0. I want to keep x squared positive still. So I'm going to subtract the 6x and add the 4. Over to the other side. Now set it up. X equals negative b plus or minus b squared minus 4 times a times c all over 2 divided by a. So x equals 6 plus or minus 36 minus 16, 20 over 2. So x equals 6 plus or minus 2 square root 5, because you have square root 4 and square root 5, over 2. So up here, so then you get x equals 3 plus or minus the square root of 5. There are your two answers. Exact answers, no decimals. Okay? Alright, let's try another one. Alright, so here we go. So I'm actually, this time, I'm going to move all three of these over so I get like a being positive. It just makes more sense to me. So subtract 7x, subtract 7x, add the 4, add the 4, add the 5x squared. So this whole side becomes 0, and then you would get 5x squared minus 5x plus 4. There's nothing I can divide everything by. So just set up the equation. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Alright, so you would get x equals 5 plus or minus the square root of negative 55 over 10. Well, but that, so now remember, this is going to be imaginary, so you get x equals 5 plus or minus I times the square root of 55 over 10. And then that would equal 1/2 plus or minus I times the square root of 55 over 10. Let's take a look at another one. Alright, so first thing I would do, subtract the 2x, add the 9. Subtract the 2x, add the 9. So you get 4x squared minus 12x plus 9 equals 0. Now we just have to set it up. X equals negative b plus or minus b squared minus 4 times a times c all over 2 times a. Okay, so you would get 12 plus or minus the square root of 0 over 8. So you would get x equals 12 over 8, which is 3 over 2. So 3 over 2. Alright, let's take a look at the next page. Now, if you notice, if you look back, it says using the discriminant. So the first problem we had 2 real solutions, the second problem we had 2 imaginary solutions, and the third problem we had 1 real. If b squared minus 4ac is greater than 0, that's probably better. If b squared minus 4ac is greater than 0, it means there's 2 real solutions. If b squared minus 4ac equals 0, it means 1 real. If b squared minus 4ac is less than 0, it means no real, 2 imaginary. Okay? See how this has the intercepts crossing twice, once, and it's above? That's what happens. Let's look at some problems with these. Okay, it says, find the discriminant of the quadratic equation and give the number and type of solutions. Okay. So, first thing, get it into the standard form. Now just calculate b squared minus 4ac. So, negative 2 squared minus 4 times 7 times negative 5. We get 144, so that means 2 real solutions. Okay, so try the next one. Subtract 3, add the 3x. Subtract 3, add the 3x. You get 4x squared plus 6x plus 9 equals 0. So 6 squared minus 4 times 9. You get negative 108, so that means 2 imaginary. Okay, let's look at the last one here. So add the 12. You get 3x squared plus 24 equals 0. So you would get 0 squared minus 3 times 4 times 24. So you can see, since it's going to be 0 minus something, you're going to get negative 288. So again, 2 imaginary solutions. Let's take a look at the next problems. All right, modeling launch objects. The function h equals negative 16t squared plus h naught. Okay, negative 16t squared is basically gravity working based on time. H naught is the original height, so is used to model the height of a dropped object. For an object that is launched or thrown, an extra term, v naught, which is the initial velocity times time, must be added to the model account for the object's initial vertical velocity, v naught in feet per second. Recall that h is the height in feet, t is the time in motion in seconds, and h naught is the initial height in feet. Okay. So we're going to need one of these two. Let's read our problem and see which one we're going to need. Alright. It says a juggler tosses a ball into the air. The ball leaves the juggler's hand 4 feet above the ground. We're probably going to need that. And it has initial velocity of 50 feet per second. We're probably going to need that. The juggler catches the ball when it falls back to 3 feet. How long is the ball in the air? Okay, so it had an initial velocity, so we definitely need to use the second equation. So we get h equals negative 16t squared plus the original velocity times the time plus the original height. So let's see. The ball leaves the juggler's hand 4 feet above the ground. So that's the initial height. So we know we have plus 4. And it has an initial velocity of 50 feet per second. So the initial velocity is 50. And we still have the negative 16t squared. And where did the height end at? 3 feet. So now before we solve anything, subtract the 3. 0 equals negative 16t squared plus 50t plus 1. Now you can't factor, so use the quadratic formula. So t equals negative 50 plus or minus 50 squared minus 4 times a times c, all over 2 divided by a. So solve that one out, bring it in completed. If you show it to me done correctly, there might be some extra credit involved, so remind me in class.